Hello, good morning. This is in continuation with the fluid mechanics class, which I'm going to take as an online teaching assignment. Okay, so coming to the stability of submerged bodies, I said that there are three kinds of equilibrium. First one is called the unstable equilibrium. Second one is called the stable equilibrium, and the third one is called as the neutral equilibrium. So in the case of the unstable equilibrium, you can see that you can see here in the case of the unstable equilibrium, you can see that the center of buoyancy is below the center of gravity. You can see here. And in the case of stable equilibrium, the center of buoyancy is above the center of gravity. Okay, so because of this, you observe that during the unstable equilibrium, the body tilts. Okay, and in the case of a neutral equilibrium, you observe that both the center of gravity and center of buoyancy are at the same point, which is at the center of the body. Okay, now when we are talking about stability of bodies, a very important point comes into picture, which is called the metacentric height. So what is metacentric height? If you have to know that, then metacentric height is defined as the distance between the metacenter and the center of gravity. And there are two methods to determine the metacentric height. First one is called the analytical method, and second one is called the experimental method. In the analytical method, see, you consider a floating body. Okay, you take a floating body. It could be a ship, for example. Take a floating body. Just please observe the floating body. Note down the diagram. We are taking a small wedge, a small portion of the body. See here. Please note down the different forces acting on the body. Now, when we have to do the derivation, we see that BB dash is equal to BM into tan theta. Therefore, BM is equal to BB dash by theta. Now, take the force, the moment of the force, that is a couple which is acting on the two bodies. When we do that, we see that two forces are acting, and the calculation is like this. Just observe here. The body is given a small angular displacement, and when the body is given a small angular displacement, you can observe what is the changes that is happening to the body. Now, BB dash is equal to I by V, you get, where I by V is called the metacentric radius, since you get GM is equal to I by V into BG. So, GM is called the metacentric height and V is the volume of the liquid displaced. Hence, for the analytical method, we take two moments, that is a couple, and the body has to be in equilibrium. So when we equate the couple, we get the center GM, which is the metacentric height. You have also the another method, which is called the experimental method, and the experimental method does not contain any derivation, but the experimental method is proven experimentally during the process of the moving of a ship or whatever is possible. So buoyancy is the upward force, which is the resisting force coming from the body, and the another one is the metacentric height. And so we have discussed about what is buoyant force, what is the effect of buoyancy and buoyant force, and what is the metacenter height, and what are the methods of calculation of metacentric height, analytical and experimental method. Thank you.